The ethers in which the oxygen atom is bonded to two different alkyl or aryl group are called mixed ether. When sodium alkoxide is heated with alkyl halide in alcoholic medium, ether is formed. This reaction is called Williamson's synthesis. If tertiary alkyl halide is heated with sodium alkoxide, elimination takes place instead of substitution to give an alkene. Hello everyone, this is Harshita Bhavasar from Vidhyaashram PU College Temple of Excellence. This is the last session of this chapter, alcohols, phenols and ethers. In the previous session, we have discussed about physical properties of phenols and chemical properties of phenols. In this session, we will discuss about classification of ethers, nomenclature of ethers and overall properties of ethers. Ethers are alkoxy or aryloxy derivatives of hydrocarbons. The general formula of ether is ROR dash. R and R dash may be alkyl or aryl ether. Okay. It may be CH3O, CH3, this is one R and R dash, or it may be CH3O, C2H5, anything alkyl or aryl, it may be present, and those are all will be considered as ethers only. Classification of ethers. Ethers are classified into two types, simple or symmetrical ether or mixed or unsymmetrical ethers. First one, simple or symmetrical ethers. The ethers in which the oxygen atom is bonded to two identical alkyl or aryl groups are called simple or symmetrical ethers. See here, diethyl ether. If we cut here one plane, it will be same images from both the side. So, it will call it as symmetrical ether or simple ether. Even in diphenyl ether also. Mixed or unsymmetrical ethers means the ethers in which the oxygen atom is bonded to two different alkyl or aryl group are called mixed ether. Here ethyl methyl ether, in between oxygen is there, that side CH3 and this side C2H5. In anisole also CH3 C6H5 is present. So these are mixed or unsymmetrical ether, that one simple or symmetrical ethers. Nomenclature. In common system, ethers are named by adding suffix ether after naming the alkyl or aryl group in the alphabetical order. Usually in common name, after all alkyl or aryl group, you have to add suffix as ether. In IUPAC nomenclature system, ethers are named as alkoxy derivatives of alkanes. For mixed ethers, the large alkyl group is selected as parent alkane. Okay. See here, CH3O CH3 dimethyl ether, methoxymethane means for methyl OXY will be added, alkoxy like that. This one anisole, methoxybenzene, and this one isopropyl methyl ether, 2-methoxy. At the second position methoxy is there, so methoxypropane is given. See here, you can take as a this structure. Okay, from this you have to start naming 1-ethoxy, 2-nitrobenzene. Okay, 1-ethoxy, 2-nitrobenzene. There is no common name for this. This is overall benzene structure. Next, structure of ether functional group. In ethers, the two bond pairs and two lone pairs of electrons around oxygen are arranged almost in a tetrahedral arrangement. The carbon-oxygen carbon bond angle is slightly greater than that of tetrahedral angle due to the repulsive interaction between two bulky groups. Due to these two bulky groups, it has repulsive nature. That's why it is having COC bond angle is slightly greater than the tetrahedral group. The CO bond length in ethers is almost the same as in alcohols. Okay. Next, methods of preparation by dehydrogenation of alcohols. Alcohols undergo dehydration in the presence of protic acids like H2SO4. If the acids are used, dehydration will take place. The formation of product depends on the experimental conditions When excess of alcohol is heated to 413 Kelvin in the presence of concentrated H2SO4, ethers are formed. When alcohols undergo dehydration in the presence of protic solvent, you may get ethers by the removal of water molecule. Here also you can use CH3OH plus. This is also same alcohol. In the presence of H2SO4, it will form CH3O, CH3 plus H2O. Okay, this is one of the example, methoxymethane and that one alcohols. Mechanism: through nucleophilic molecular reaction, that is SN2 reaction involving the attack of alcohol molecule on a protonated alcohol as indicated above. Okay, this is ethanol. When protonation has been taken place, CH3, CH2, O will be get added here, and that proton, whatever it has been added, will given to the carbon of ethanol, and it will form CH3, CH2, OH and CH2, CH3 water removal. That OH will be involved for the oxygen, which is now electropositive at this nature. It is electrophilic in nature. It will form CH3, CH2, O, CH2, CH3, and this is ether. Okay, and removal of proton. Next, Williamson's ether synthesis. When sodium alkoxide is heated with alkyl halide in alcoholic medium, ether is formed. This reaction is called Williamson's synthesis. When sodium alkoxide treated with alkyl halide by the method of SN2 reaction, ether will form. Okay, when sodium phenoxide is heated with methyl iodide, methyl phenyl ether is formed. When sodium phenoxide is heated. Okay, CH3ONA plus methyl iodide CH3I reacted with through SN2 reaction, it will form CH3 plus sodium iodide will be formed. Okay. When sodium alkoxide reacted with alkyl halide, it will form ether and sodium iodide. When sodium phenate is treated with methyl iodide, it will be carried out through SN2 reaction. It will form anisole OCH3, that is anisole plus NaI. Okay, this reaction for this one, and this reaction is given for this. When sodium phenate is heated with methyl iodide, it will form methyl phenyl ether called anisole is formed. Limitations of Williamson synthesis. This reaction is not suitable for the preparation of ethers from secondary and tertiary alkyl halides. If tertiary alkyl halide is heated with sodium alkoxide, elimination takes place instead of substitution to give an alkene. Okay, this reaction is not suitable for preparation of ethers from secondary or tertiary alkyl halides. If tertiary alkyl halide is heated with sodium alkoxide, elimination reaction takes place instead of substitution to give an alkene. It is because alkoxides are not only nucleophiles but also strong bases. See here, tertiary bromide is reacting with sodium alkoxide, which gives 2-methyl propene, okay, with sodium bromide. Next, physical properties. Dimethyl ether and ethyl methyl ethers are gases. All other ethers are colorless liquids. First two ether groups are lower member of ethers are gases. All other ethers are colorless liquids. The bond between the oxygen atom and the carbon atom of the alkyl groups in an ether molecule are polarized due to a difference in electronegativities between carbon and oxygen. The bond in the oxygen atom and the carbon atom is in the alkyl groups have difference because of the electronegativity, it get polarized. Since carbon and oxygen bond is polar bond, ether possesses a net dipole moment even if they are symmetrical. Okay. it is having night dipole moment, even that ether will have the symmetrical in nature. Dipole moment of diametric ether is 1.3 dBi and dipole moment of di inside ether is 1.18 dBi. The weak polarity of ethers do not appreciably affect their boiling points, which are comparable to those of the alkenes of comparable molecular masses, but are much lower than the boiling points of alcohols. See here N-pentane, this is ethoxyethane and butanol. It is having 390 Kelvin, this is 307.6 Kelvin and that is 309.1 Kelvin. They are giving the comparison between alkane, ethers and alcohol, but it is in between of alkane and alcohols due to the electronegativity difference between carbon and oxygen. Also, the weak polarity of ethers will not give the appreciable boiling point. The difference in boiling points of alcohols and ethers is due to the presence of hydrogen bonding in alcohols. Lower ethers are visible in water to some extent. This is due to the formation of hydrogen bonds with water molecules. Lower members of ethers and also the alcohols have hydrogen bond formation. That is why having high boiling point. The solubility decreases with increase in the number of carbon atoms. The relative increase in the hydrocarbon portion of the molecule decreases the tendency of hydrogen bond formation. Ethers are appreciably soluble in organic solvents like alcohol, benzene, acetone, etc. Okay. When the number of carbon atoms increased in ether, obviously the boiling point or boiling point will increase, solubility will decrease, and there is a relative increase in the hydrocarbon portion of the molecule, decreases the tendency of the hydrogen bond formation. Okay. This is about physical properties of ethers. Next, chemical properties. Chemically, ethers are less reactive. The low reactivity of ethers is due to the absence of active site in its functional group. However, under specific conditions, ethers undergo some chemical reactions. Chemically, ethers are less reactive due to the absence of active site in its functional group. Reactions involving cleavage of carbon and oxygen bond. When ethers are heated with limited amount of hydrogen halide, mixture of alcohol and alkyl halide is formed. When ether treated with alkyl halide, that alcohols will form and alkyl halide will also form. The order of reactivity in hydrogen halide is first HI, hydrogen iodide, hydrogen bromide, then later hydrogen chloride. Here R may be any alkyl CH3, C2H5, like that alkyl or aryl. X you know, Cl, I, Br, like that. Alkyl aryl ethers react with hydrogen halide to form phenol and alkyl halides. Alkyl aryl ethers will form phenols in the presence of hydrogen halide. During this reaction, alkyl oxygen bond is cleaved. This is due to the more stability of aryl oxygen bond due to the partial double bond character. Here, alkyl oxygen bond will break or cleave due to the stable aryl oxygen bond is formed. Electrophilic substitution. The alkoxy group of aromatic ethers is ortho at para-directing and activates the aromatic ring towards the electrophilic substitution in the same ways as in phenol. This electrophilic substitution will take place as how the electrophilic substitution was taking place in phenol. See here, due to the lone pair of electrons present towards the oxygen, it will involve in the conjugation of ethers and also it will form the stabilized aryl ether formation. Okay. Next, halogenation. Alkyl ethers undergo usual halogenation in the benzene ring. Example, anisole when reacted with bromine in the presence of ethanoic acid, it will form para-bromoanisole and ortho-bromoanisole with hydrogen bromide will be released. Okay. In the absence of iron bromide catalyst, it is due to the activation of benzene ring by methoxy group, isomer is obtained in 90% yield. This is halogenation. Next, Friedel-Crafts alkylation. Anisole undergoes Friedel-Crafts alkylation, that is alkyl group is introduced at ortho and para positions by reaction with alkyl halide in the presence of anhydrous aluminium chloride as catalyst. When anisole treated with chloroform in the presence of anhydrous aluminium chloride, it will form 2-methoxytoluene and 4-methoxytoluene with hydrogen halide liberation or hydrogen chloride liberation. Here also major and minor 2 products will be formed, but ortho and para positions only, the both products will be formed. FRIEDEL-Craft acylation. When anisole is treated with acetyl chloride in the presence of anhydrous aluminium chloride, ortho and para acetyl derivatives of anisole is formed. See here, anisole treated with acetyl chloride in the presence of anhydrous aluminium chloride, 2-methoxyacetophenone and 4-methoxyacetophenone will form, but 2-methoxy will be minor, 4-methoxyacetone will be major. Here also 2 products will be formed and both will be at ortho and para positions. Next, nitration. Anisole react with a mixture of concentrated sulfuric and nitric acid to yield a mixture of ortho and para nitroanisole. When anisole treating with nitrating mixture called concentrated H2SO4 and concentrated HNO3, it will form 2-nitroanisole and 4-nitroanisole. 4-nitroanisole will be major and 2-nitroanisole will be minor in the product. This is about overall discussion of ethers, and I hope you have understood completely whatever I have taught in this session about ethers, its classification, its preparation, and also about its physical and chemical properties. This end up with the alcohols, phenols and ethers chapter. We'll come up with a new upcoming chapter. Till that, thank you.